If early galactic formation rate ends up being faster than previously thought, what experimental techniques do we have to isolate this additional early light? So the experimental techniques that we would have would be deeper infrared sensing. So referring to the James Webb Space Telescope, observations of mature, highly ordered, structured, spinning galaxies at very high redshifts. Well, that redshift means that the light is going to be far redder than, say, the Hubble Space Telescope's capabilities were, and potentially could be even higher than the Webb telescope's longest wavelength imaging capability is. They have spectroscopy over a wide range of wavelengths, very long infrared, near and far infrared, but that does not cover perhaps the entirety of the redshift range in which galaxies could form, and we just don't know. The problem I have is I've told other people, and people like Eric Lerner and the Thornbirds or Thunderbolts, I don't know, these guys, I'm having a reaction video on my other channel, which you can subscribe to, Professor Keating Experiments. We'll be discussing that more and more. There's recent claim that the CMB itself comes from these early galaxies. It's total nonsense, blown out of proportion for engagement farming to the tune of 2 million views on Twitter alone. But that was a really kind of excessive interpretation of what the authors claim was at most a 1% contribution to the CMB, which I don't even believe is correct, because the spectral distortions and the CMB polarization measurements that I do have completely invalidated additional energy injection sources other than black body thermal radiation left over from the formation of the first elements on the periodic table and formed during the epoch of recombination. So we'll talk about that. I'm going to definitely talk about that the next office hours. So make sure you join up. Be like memes.